Hey Condors, it's your boy Mr. Roberts here with a little social distancing science. Hey, let's check out our agenda for today and see what we're going to do. But before we do that, don't forget, make sure that you hit that subscribe button, and while you're at it, mash that little bell so you get notifications so you don't miss a single upcoming episode of Social Distancing Science. Let's look at our agenda. Okay, today we are going to do 6 things. We've got a lab about casting shadows. We're going to read about solar eclipses. We're going to read about total lunar eclipses, and we're going to do a little thinking about that. And then we're going to read about partial lunar eclipses, and we'll do a little thinking about that. We'll be finishing up this lesson on eclipses on Friday. Let's get to it. So, log into McGraw Hill. We are on the activity lab casting shadows. So, what is a solar eclipse? As the sun shines on the moon casts a shadow that extends out into space. Sometimes the moon passes between the Earth and the sun. This can only happen during the new moon phase, though. Let's investigate. Okay. There we go. So, I modified this a little. Let's go to the classroom and check this out. Hey, we're here in the classroom. Let me turn off a little lights because we're going to be dealing with some other lighting sources. Lights off. Okay. I went ahead and made this handy dandy. Hey, what do you think this is a model of? Oh, it's a model of the Earth. We're like right there, right? Anyway, here's my model of the Earth, and attached to it is a moon. Now, based on the sizes that these are printed, technically, the moon would be like 10 feet away, and the sun would be about 3/4 of a mile away. That doesn't really work for me. I can't simulate that very easily. So, we are going to realize that this is a model, but the distances are not to scale. And we've got a handy light source. Later, I'll tell scary stories. But for now, let's see what happens. So we've got our Earth and our moon. And what happens when there's a new moon? So you see how on the moon that half of the moon is illuminated, but it's the half away from the Earth. The people on Earth are seeing no moon. And what is happening on the planet? Why, do you see that black circle? That's an eclipse. Okay, back to the curriculum. So, can you make some observations? What did you see? And let's see what kind of questions we should answer. So, can you explain the relationship between the shadows and the solar eclipses? Now, in this lab, we use 2 different size balls, a big one and a small one. What did each of them represent? Can you explain a lunar eclipse using words and illustrations? Fill that out, pause the video, come back when you're done. Let's go on to the next activity. What is a solar eclipse? So as the sun shines on the moon casts a shadow that extends out into space. Sometimes the moon passes between Earth and the sun. Solar eclipses can only occur during the new moon phase. When Earth, the moon, and the sun are lined up, the moon casts a shadow on Earth's surface. When the moon's shadow appears on Earth's surface, a solar eclipse is occurring. As Earth rotates, the moon's shadow moves along Earth's surface. The type of eclipse you see, total or partial, depends on where you are in the path of the eclipse. So notice how in this picture, much like in our little demo we just did, the shadow did not cover the entire Earth. It only covered a portion of the Earth. You can only see a total solar eclipse from within the moon's umbra. During a total solar eclipse, the moon appears to cover the sun completely as shown in the figure below. Then the sky becomes dark enough that you can see stars. A total solar eclipse lasts no longer than about 7 minutes. Let's see what it looks like. So you've got like a little, okay, so the sun's getting smaller. And then, so you just have that ring around the edge of the moon. And then as we come out of the eclipse, the sun gets larger again. You can see a partial solar eclipse from within the moon's much larger penumbra. The stages of the partial solar eclipse are similar to the stages of a total solar eclipse, except the moon never completely covers the sun. Okay, let's go to what is a lunar eclipse? Just like the moon, Earth casts a shadow into space. As the moon revolves around Earth, it sometimes moves into Earth's shadow. A lunar eclipse occurs when the moon moves into Earth's shadow. Then Earth is in line between the sun and the moon. This means that a lunar eclipse can occur only during a full moon phase. Hey, let's see if we can model that real quick. Let's go back to the classroom. And we'll turn some lights down. We'll grab our model and our sun. So here's my sun, right? Normally, during a full moon, you have something like this, where the moon is illuminated. But what happens when the Earth is in the way? All of the sunlight is blocked by the Earth, and it's a lunar eclipse. Okay, now like the moon's shadow, Earth's shadow has an umbra and a penumbra. Different types of lunar eclipses occur depending on which part of the Earth's shadow the moon moves through. Unlike solar eclipses, you can see any lunar eclipse from any location on the side of the Earth facing the moon. Total lunar eclipses. When the entire moon moves through Earth's umbra, a total lunar eclipse occurs. The moon's appearance changes as it gradually moves into Earth's penumbra, then into Earth's umbra, back into Earth's penumbra, and then out of Earth's shadow completely. Let's do a little 3D thinking about lunar eclipses. So, you've just learned that during a total lunar eclipse, the entire moon passes through Earth's umbra. The moon gradually darkens until a dark shadow covers it completely. Construct an explanation to describe how a total lunar eclipse would look compared to a total solar eclipse. Pause the video, answer it, and let's continue on in a moment. Okay, we're going to do a little reading again. Now, what about partial lunar eclipses? You can still see the moon even within Earth's umbra. Although Earth blocks most of the Earth's rays, Earth's atmosphere deflects some sunlight into the Earth's umbra. This is why you can often see the unlit portion of the moon on a clear night. This reflected light has a reddish color and gives the moon a reddish tint during a total lunar eclipse. Ooh, that's kind of creepy looking. When only part of the moon passes through Earth's umbra, a partial lunar eclipse occurs. The stages of a partial lunar eclipse are similar to those of a total lunar eclipse, except the moon is never completely covered by Earth's umbra. The part of the moon in Earth's penumbra appears only slightly darker, while the part of the moon in Earth's umbra appears much darker. Okay, let's go on. We've got another 3D thinking, and we're done for the day. So, what patterns did you notice between solar and lunar eclipses? How do those patterns impact who can see each type of eclipse? Explain your reasoning. Fill this out. Hey, I want you guys to have a great day, and I will see you again on Friday.